So welcome. This is a work video based on differential equations. So we are going to do few questions based on differential equations. So we shall start from the very basic questions and slowly we go to the higher level of questions. So the very first question is very simple. So I'm starting from very basic question. So the question will be find general solution. GS means general solution. General solution of the following differential equation. Of the following differential equation. D dot E is differential equations, and the first one is over here. That will be the common question for everything. The first one is dy by dx equals to 1 plus y times 1 minus 2x. So the method that I'm going to use it on is called as variable separable. What is the method? Variable separable. What is the meaning of variable separable? Separating the variables. So I get dy times 1 upon 1 plus y equals to 1 minus 2x times dx. What I have done it out? Y and dy terms on one side, x and dx terms on the other side. Then apply integral on both sides. Integral of 1 plus y is 1 upon 1 plus y is ln 1 plus y. Absolute value of 1 plus y equals to 1 integral is x, 2x integral is x square plus c. That's all. That's going to be the answer. If you want it out to further simplify it out, you can see how am I simplifying it out, because try to write all the answers in the form of y equal to f of x. So make y equals to f of x, make y as a subject. So what should I be doing it out? 1 plus y equals to e power x minus x square plus c. So 1 plus y equals to e power x minus x square times e power c. E power c is another constant. So 1 plus y equals to a times e power x minus x square. So y equals to a times e power x minus x square minus 1. That's going to be the answer. Now come to the second question, or B, dy by dx equals to y tan x. Now what am I going to do? 1 upon y dy equals to tan x dx. Then again I do integral on both sides. 1 upon y integral is ln y. Tan x integral is ln secant x. Remember, that is the formula for tan y, tan integral ln secant x. And c, instead of writing c, I am going to write ln c. So that what is the necessity? So that my simplification will become easier. You can write the constant in terms of answers so that you can simplify. Ln and ln gets cancels, y equal to c secant x. So sometimes you can change the constant. Instead of writing c, you can write ln c also. That's question B. Now come to question C. Cos square x dy by dx equals to y square sine square x. So what am I going to do that now? 1 upon y square dy equals to sine square x upon cos square x dx. Then again I do the integral of this one. So what does that becomes? Integral of y power minus 2 dy equals to integral of sine square x upon cos square x is tan square x dx. So this becomes y power minus 1 upon minus 1 equal to integral of tan square x. There is no formula, so secant square x minus 1 dx. So negative 1 upon y equal to integral of secant square x is tan x, and integral of 1 is x plus c. Now I have to make y as a subject, remember. So what am I going to do? I am going to do the reciprocal on both sides. So negative y equals to 1 upon tan x minus x plus c. So what is y? Y equals to negative 1 upon tan x minus x plus c. That's going to be the answer. Next one, dy by dx equals to 2 e power x minus y. So what am I going to do? Dy by dx equals to 2 e power x upon e power y. So e power y dy equals to 2 e power x dx. Then I do integral on both sides. E power y integral is e power y, e power x integral is e power x plus c. But now I want to make y as a subject. For that, what am I going to do? Apply ln on both sides. So y ln e equals to ln of 2 e power x plus c. So y equals to ln of 2 e power x plus c. That's going to be the answer. The next one, x square dy by dx equals to y plus xy. What am I going to do? X square dy equals to y common 1 plus x times dx. Now 1 upon y dy equals to 1 plus x upon x square dx. So now again integral on both sides. Ln y equals to, this is integral of 1 upon x square plus x upon x square dx. So ln y equals to 1 upon x square integral is negative 1 upon x. This is x upon x square. 1x, x gets cancels, 1 upon x. What is 1 upon x integral? Ln absolute value of x plus c. So ln y minus ln x equals to c minus 1 upon x. So ln y upon x equals to c minus 1 upon x. So y upon x equals to e power c minus 1 upon x. So y upon x equals to e power c times e power minus 1 upon x. E power c is some other constant a. So y upon x equals to a times e power minus 1 upon x. So make y as a subject. Y equals to a x e power negative 1 upon x. Now next level of the questions, maybe going to the second level of the questions, 2a. So what am I going to do? Dy upon dx equals to tan y tan x. So what am I going to do? 1 upon tan y dy equals to tan x dx. 1 upon tan y is cotangent y. Cot y dy equals to tan x dx. Cot y integral is ln sin y equals to tan x integral is ln secant x plus again constant you write as ln c, so that easy for simplification. So ln sin y equals to ln c times of secant x. So ln cancels. In this second question there was no necessity to make y as a subject, so sin y equals to c secant x. We can leave it off over here. That was only in the first question where we had to make y as a subject. Now the next one, sin y cos x dy by dx equals to x cos y upon cos x. This is another question. So what am I going to do? Sin y upon cos y dy equals to x. 1 upon cos x times cos x is cos square x dx. So it becomes tan y. Tan y dy equals to x secant square x dx. Now integral on both sides. Tan y integral. Tan y integral is ln secant y equals to, this is integration by parts. First function, second function. First function, integral of second function, tan x minus integral of derivative of first function, 1. Integral of second function is tan x. So it becomes ln secant y equals to x tan x minus tan x integral. Tan x integral is ln secant x plus c. Now coming to the next question. 1 plus x square dy by dx equals to x bracket 1 minus y square. So 1 minus y, 1 upon 1 minus y square dy equals to integral of x upon 1 plus x square dx. So what am I going to do? I am going to do the partial fractions of that. 1 plus y times 1 minus y dy equals to integral of x upon 1 plus x square dx. What am I going to do? Multiply and divide by 2. Why am I multiplying and dividing by 2? There is a formula. Any function in the denominator, its derivative is there in the numerator, then it is ln denominator. Now, partial fractions for this, I am directly writing the partial fractions, or you can still do the partial fractions. 1 plus y times 1 minus y equals to a upon 1 plus y plus b upon 1 minus y. So 1 equals to a times 1 minus y plus b times 1 plus y. Now y equals to 1, so 1 equals to 2b, b equals to 1 upon 2, y equals to negative 1, 1 equals to 2a, a equals to 1 upon 2. So what will be the partial fractions? 1 upon 2 upon 1 minus y plus 1 upon 2 upon 1 plus y dy equals to integral of 2x upon 1 plus x square dx 1 upon 2. We can clearly see that 1 upon 2, 1 upon 2, 1 upon 2 cancels. So this is ln 1 minus y upon minus 1. Don't forget to divide by the derivative of basic function. Ln 1 plus y is ln of 1 plus x square, plus preferably to have ln c as a constant. So minus ln of 1 minus y plus ln of 1 plus y equals to ln of c times 1 plus x square. So this becomes ln of 1 plus y upon 1 minus y equals to ln of c times 1 plus x square. We can clearly see that ln cancels. That's going to be the answer. Next one, cos y sin 2x dy by dx equals to cot x cosecant y. So what am I going to do? Cos y upon cosecant y dy equals to cot x upon sin 2x dx. Now what does that becomes? Cos y sin y. 1 upon cosecant y is sin y. Sin y dy equals to cot x is cos x upon sin x. Sin 2x is 2 sin x cos x dx. Then cos x cancels. Multiply and divide by 2. So 1 upon 2 sin 2y dy equals to 1 upon 2 cosecant square y, cosecant square x dx. So we can clearly see that 1 upon 2, 1 upon 2 cancels. Now minus cos 2y upon 2 equals to minus cot x plus c. Rather than plus c, I will be writing it as c upon 2. Why do I write c upon 2? So that when I multiply by minus, but directly I get it out, cos 2y equals to 2 cot x plus c. This is going to be the answer. So I take in the constant as minus c upon 2. You can take it as plus c also, does not matter. You are going to get the same answer. Next one, e power x plus y dy by dx equals to x times 2 plus e power y. So e power x times e power y dy equals to x times 2 plus e power y dx. So it becomes e power y upon 2 plus e power y dy equals to x times e power minus x dx. Then apply integral on both sides. We can see that the formula, the same formula I can use. You take any function in the denominator, its derivative is there in the numerator, then the answer is ln denominator. So this becomes ln 2 plus e power y equals to this integration by parts. First function, second function. First function, integral of second function is minus e power minus x minus integral of derivative of first, integral of second. So what am I going to get it out? Ln 2 plus e power y equals to minus x e power minus x plus integral of e power negative x. What is integral of e power negative x? Is minus e power negative x plus c. This is going to be the answer. Now to the next level of the questions. That was second level. Now we go to the third level of the questions. So dy by dx equals to y e to the power of x. So starting 1 upon y dy equals to e power x dx. Apply integral on both sides. Ln y, this was an easy question, equals to e power x plus c. Next, dy by dx equals to x e power y. So 1 upon e power y dy equals to x dx. Integral, so integral of e power negative y dy equals to integral of x dx. So minus e power minus y equals to x square upon 2 plus c. Part C, dy by dx equals to y cos x. So 1 upon y dy equals to cos x dx. Integral, so it becomes ln y. Cos x integral is sin x plus c. So y equals to e power sin x plus c. Now e power c is another constant. So y equals to e power sin x times e power c. E power c is another constant, a times e power sin x. Next, dy by dx equals to x cos y. So 1 upon cos y dy equals to x dx. So it is secant y equals to x dx. Secant y integral. You need to memorize or you can prove it out. Secant y integral is ln secant y plus tan y equals to x square upon 2 plus c. Next, dy by dx equals to 1 plus cos 2x times cos y. So 1 upon cos y dy equals to 1 upon cos 2x dx. It becomes secant y dy equals to 1 plus cos 2x dx. Secant y integral is ln secant y plus tan y equals to 1 integral is x. Cos 2x integral is sin 2x upon 2 plus c. Then the next one, dy by dx equals to 1 plus cos 2y times cos x. So 1 upon 1 plus cos 2y dy equals to cos x dx. 1 upon cos 2y. We know the formula. 1 upon cos 2y is 2 cos square y dy equals to cos x dx. So we know the formula. Cos 2x is 2 cos square x minus 1 from the formula booklet. So 1 plus cos 2x becomes 2 cos square x. This is the formula that has been used over here. So it becomes 1 upon 2 secant square y dy equals to cos x dx. Then 1 upon 2 tan y equals to secant sin x integral is cos x integral is sin x plus c. Those were the questions with the basic levels. Now we are going to find it out a particular solution. Find particular solutions means we have to find the value of c also. So for that, this is the next level. So dy by dx equals to sin x times cos square x. So what I'm at, y equals to 0, x equals to pi upon 3. So the c value has to be found out. So dy equals to cos square x times sin x dx. I apply integral on both sides. Now we have to check that cos x derivative is minus sin x. So minus is missing. So multiply by minus and minus. Why am I doing like that? We have one formula. Take any function to the power of n times that function derivative. The formula will be that function to the power of n plus 1 upon n plus 1. Take any function and to the power of n, and without that power n, its derivative should be present. So over here we can clearly see that this is f of x and this is f prime x. Then my answer will be f of x whole to the power of n plus 1 upon n plus 1 plus c. But it has been given that y equals to 0, x equals to pi upon 3. So 0 equals to minus cos pi upon 3 whole cube upon 3 plus c. What is cos pi upon 3? 1 upon 2. 1 upon 2 whole cube is 1 upon 8 upon 3 plus c. So c equals to 1 upon 24. So what is that? Y equals to 1 upon 24 minus 1 upon 3 cos cube x. Next, dy by dx equals to secant square x secant square y when y equals to 0, x equals to pi by 4. So 1 upon secant square y dy equals to secant square x dx. Apply integral on both sides. 1 upon secant square is nothing but what? Cos square. Cos square y dy equal to secant square x dx. Cos square y is 1 plus cos 2y upon 2 dy. Integral of secant square x is tan x plus c. So 1 upon 2 y plus 1 upon 2 cos 2y integral is sin 2y upon 2 equals to tan x plus c. Now the limits are given. Y equals to 0, x equals to pi upon 4. So 0 plus 1 upon 4 sine of 2 times pi upon 4 equals to tan pi upon 4 plus c. So what does that becomes? 1 upon 4 sine pi by 2 is 1 equals to 1 plus c. So c equals to 1 upon 4 minus 1. C equals to, what am I doing there? I am simplifying it out, the values, so that I should be able to get that answer. So minus 3 upon 4. So I have substituted y equals to 0 and x equals to pi by 4. So tan pi by 4 value is 1, sin pi by 2 value, over here it is pi by 2, 2 times 1, 2 times 2, sin pi by 2 is 1. So what am I going to get it out? Minus 3 by 4. So 1 upon 2y plus 1 upon 4 sin 2y equals to tan x minus 3 upon 4. Multiply by 4 on both sides. So it will become 2y plus sin 2y equals to 4 tan x minus 3. That's going to be the answer. Next, dy upon dx equals to 2 cos square y cos square x, and the particular values are given: y equals to pi upon 4, x equals to 0. So what am I going to do? 1 upon cos square y dy equals to 2 cos square x dx. So it becomes secant square y dy equals to 2 cos square x is nothing but what is 2 cos square x? Just now we have done 1 plus cos 2x dx integral. So secant square y integral is tan y equals to x plus sin 2x upon 2 plus c. What are the values are given? X equals to 0, y equals to pi by 4. So tan pi by 4 equals to 0 plus sine 0 by 2 plus c. So 1 equals to c. So what will be the answer? Tan y equals to x plus sine 2x by 2 plus 1. Then part D, 1 minus x square dy by dx equals to xy plus y. And what is x value? 0.5. And what is y value? 6. So 1 upon y dy equals to x plus 1 upon 1 minus x square dx. So 1 upon y dy equals to 1 plus x. 1 minus x square can be written as 1 plus x times 1 minus x dx. What can I do? 1 plus x cancels. So it is ln y equals to ln 1 minus x upon minus 1 plus ln c. Better to take ln c. So ln y plus ln 1 minus x equals to ln c. So ln of y times 1 minus x equals to ln c. Then what will happen? Ln and ln gets cancels. Y bracket 1 minus x equals to c. What are the values of x and y given? X is 0.5 and y is 6. So 6 times 1 minus 0.5 equals to c. So c equals to nothing but how much? 3. So what is going to be the answer? Y times 1 minus x equals to 3. Now coming to maybe the last question, so that we'll end this video over here. 2 bracket of 1 plus x dy by dx equals to 1 minus y square when x equals to 5, y equals to 1 upon 2. So 2 upon 1 minus y square equals to 1 upon 1 plus x dx and dy over here. Then what am I going to do? Apply the integral on both sides. So now I'm going to do the partial fractions for this. 2 upon 1 plus y times 1 minus y equals to a upon 1 plus y plus b upon 1 minus y. So 2 equals to a times 1 minus y plus b times 1 plus y. Plug in y equals to 1, 2 equals to 2b, b equals to 1, y equals to negative 1, 2 equals to 2a, a equals to 1. So what will be the partial fractions will become? 1 upon 1 plus y plus 1 upon 1 minus y dy equals to integral of 1 upon 1 plus x dx. So it becomes ln 1 plus y plus ln 1 minus y upon minus 1 equals to ln 1 plus x plus ln c. So it becomes ln 1 plus y upon 1 minus y equals to ln of c times of 1 plus x. Ln cancels. So 1 plus y upon 1 minus y equals to c times of 1 plus x. This is going to be the answer. But he gave the values of x and y. What was that? X equals to 5, y equals to 1 upon 2. 1 plus 1 upon 2 is 3 upon 2. 1 minus 1 upon 2 is 1 upon 2. C times 1 plus 5 is 6. So 3 equals to 6c. C equals to 1 upon 2. So what will be the answer? 1 plus y upon 1 minus y equals to 1 plus x upon 2. So that completes the particular solution. So that completes the video based on differential equation from the standard level to the high level. See you in the next video. Bye.